Any planned movement of material from one place to another using ropes, chains, hoists, or other types of equipment is called rigging. The term rigging refers not only to this movement, but also to the equipment used to accomplish the job. A simple block and tackle is one of the most basic devices that can be used to lift a load. A block and tackle allows you to lift an object much higher than would be possible with just your arms. In fact, a block and tackle can be used to lift an object to just about any height, provided that there is a supporting structure from which to hang the block and that the rope is long enough. In this part, we'll examine the components of a simple block and tackle. We'll also see how to inspect a simple block and tackle and how it can be used to lift a load. The basic parts of a simple block and tackle are a block and a rope. The block consists of a frame, a pulley called a sheave, and a support hook mounted on top of the frame. The support hook is used to hang the block from a supporting structure. The rope passes over the sheave and has a load hook attached to its end. The block can be thought of as dividing the rope into two sections. One part of the rope is attached by the load hook to the load to be lifted. This part is referred to as the load line. The other part of the rope is pulled by the rigger performing the lift. This part is called the hauling line or the fall line. Before any load is lifted, it's important to determine whether the lift can be performed safely. The first step in making this determination is finding out how much the load weighs. In some cases, the load's weight is stamped directly on the load, or the weight may be stamped on a nameplate attached to a piece of equipment. For a load of material, you may have to check the manufacturer's specifications or use standard weight charts to estimate the weight. Once you know how much weight you'll be lifting, the next step is to select the correct block and tackle for the job. The block must be the right size and type for the rope you'll be using, and the rope that's chosen must have a breaking strength that provides the approved safety factor as outlined in your company procedures. Breaking strength is the maximum load a rope can lift before it begins to break apart. Once you've assembled the needed equipment, the next step is to carefully inspect the block and tackle for any signs of excessive wear or damage. After you've thoroughly inspected the equipment, the next step is to select an overhead support from which to hang the block. The support structure must be able to support the weight of the load, the block and tackle, and the force you'll exert to lift the load. In this example, the support hook is used to hang the block from the structural beam in this covered work area. Once the block is securely hung overhead, attach the load hook to the load. To lift the load, grasp the hauling line firmly in both hands. Set your feet about shoulder width apart and pull down in a smooth, even motion, keeping your back straight. At the end of the downward pull, hold the rope in one hand while you move your other hand up the rope to establish a new grip, and pull again. Continue this process until the load is at the desired height. A block and tackle, like most machines, makes it possible for you to perform more work than would be possible without it. A block and tackle is able to do this because it provides a mechanical advantage. In general, mechanical advantage is defined as the advantage gained in transmitting force through the use of a machine. This advantage is expressed as a ratio. The ratio compares the force that the machine applies to a load to the force that you apply to the machine. To calculate mechanical advantage for a simple block and tackle, we divide the weight of the load by the force that's required to hold the load. For a simple block and tackle, the mechanical advantage equals 1. That means the force required to hold the load equals the weight of the load. Although a simple block and tackle allows the rigger to lift a load high above his head, it doesn't provide any advantage in terms of lifting capacity. In fact, the mechanical advantage of 1 that a simple block and tackle provides considers only the effort required to hold the weight. If a rigger wants to use a simple block and tackle to raise a load, more effort will be required. A compound block and tackle uses 2 or more blocks and pulleys called sheaves to create a greater mechanical advantage than a simple block and tackle. For example, this compound block and tackle has 2 blocks and 5 sheaves. Multiple sections of rope called parts are threaded or reeved through the sheaves. The The rope sections or parts are reeved or threaded through the two blocks in such a way that each part of the rope supports a portion of the load weight. In this example, the block and tackle arrangement creates 5 parts of rope. If the block and tackle were 100% efficient, each part would support exactly 1/5 of the total weight of the load. But some loss of efficiency always occurs in a block and tackle. An important part of selecting the right compound block and tackle to lift a load is determining how many parts of rope you need. To do this, you can use a formula for calculating a value called the efficiency factor. The efficiency factor is a reference value that can be looked up in a conversion table to determine how many parts of rope are required to create the mechanical advantage you need. But before you can use the formula, you have to gather some information. First, you need to know how much weight you can comfortably lift. Whenever you perform a lift, you may be required to hold the load suspended in air while it's repositioned. So your lifting capacity must also take into account your ability to hold the suspended load for a period of time. There are several ways to determine your lifting capacity. One method is to rely on personal experience. Over time and several lifts, you'll probably develop a good sense of your capacity. Another method is to make several test lifts with a simple block and tackle. Begin with a lightweight object, then test lift heavier loads until you reach a weight that's difficult to lift and hold. The weight of the load in your final test lift will equal your lifting capacity. Another method for testing your lifting ability is to attach a device called a dynamometer to measure the amount of force exerted as you pull against it. Before you can use the formula to calculate the efficiency factor, you need one other piece of information. In addition to knowing your lifting capacity, you also need to know the weight of the load. The load weight may be stamped on the load itself or on an identification plate. It may also be listed on a shipping label or in the manufacturer's specifications. But for some loads, you may need to estimate the weight or weigh the load on a scale. Once you know your lifting capacity and the weight of the load, you can use the formula to determine the efficiency factor. Let's look at an example to see how it works. In this example, the load weighs 312 pounds. Our rigger knows that he can comfortably lift 80 pounds. The weight of the load divided by the lifting capacity of the rigger equals the efficiency factor. In our example, 312 divided by 80 gives us an efficiency factor of 3.9. Next, the rigger must look up the efficiency factor in a conversion table to see how it corresponds to the number of parts of rope in a compound block and tackle. In this table, our calculated efficiency factor of 3.9 falls in between the values for 4 and 5 parts of rope. To be on the safe side, always round up to the higher number. So in our example, the rigger would need a compound block and tackle with 5 parts of rope. A key point to remember is that blocks must be chosen so that their sheaves will equally distribute the weight of the load when the rope is properly reeved through them. So for our example load, the rigger needs 2 blocks that will create 5 parts of rope when they're properly reeved. To do this, he selects a block with 3 sheaves and a block with 2 sheaves. In this part, we'll examine the basic parts and function of a compound block and tackle. Then we'll see how a compound block and tackle can be set up and used to lift a load. A typical compound block and tackle has an upper block called the fixed block and a lower block called the movable block. The fixed block has a support hook attached to its frame for hanging the block and tackle. The movable block has a load hook underneath the block for attaching to the load. Each block has grooved pulleys or sheaves that guide the rope as it passes through the block. In this configuration, the movable block has a device used to tie off the end of the rope. You may hear this device referred to as a becket. The sections of rope that pass through the blocks are called parts or falls. Each part of rope in the compound block and tackle supports a portion of the total load weight. The section of rope that's pulled to begin the lifting process is referred to as the hauling line. You may also hear this section of the rope called the hoisting line, the fall line, or the running part. The other end of the rope is tied off to one of the blocks. This end is commonly known as the dead end. After the lift planning session, the next step is to select the appropriate block and tackle for the job. Blocks should be selected so that they will create the appropriate number of parts of rope. A key point to remember is that blocks should be chosen so that their sheaves will equally distribute the weight of the load when the rope is properly threaded through them. If the number of sheaves in the blocks is balanced, the number of parts of rope created will always equal the number of sheaves. For example, to create 5 parts of rope, you would choose one block with 3 sheaves and one with 2 sheaves. When the rope is threaded through these blocks properly, it will create 5 parts of rope. In order for a compound block and tackle to work properly, it's essential that the rope be threaded through the sheaves in the correct manner. This is called reeving the blocks. Because there are so many possible combinations of blocks and sheaves, it would be impossible to show all of the different reeving patterns. So, anytime you have to reeve a new compound block and tackle, you should check a rigging handbook or the manufacturer's instructions, or ask your supervisor for the appropriate reeving diagram.